In this episode, I'm going to look at a Grundig TK747. This is a stereo solid-state reel-to-reel tape recorder. Complaint on this one is, no matter what speed it's set to, it only operates at 1 7/8 IPS. Let's check it out. This is a TK747 Grundig stereo 7-inch reel-to-reel. The complaint on this unit is it's stuck in 1 7/8 IPS. So how do we work this thing here? Let's see here. Should be a power switch on here somewhere. There it is, right there, power switch. That cover is kind of nicely broken. Oops, sorry. As you can hear, it's got solenoid control. Here's our tape speed selector, which doesn't even want to move. It's probably gummed up is what more than likely the problem is on this one. Let's just throw a tape on it. Someone's gonna complain about this. I can just sense it. That somebody's gonna be upset that I'm going to put a small reel on, and they're gonna say, you can't do that, you have to have the same size reels. And, well, I don't. It just means that I have to be sure I have my hand near the spool when stopping it so that the larger reel won't continue to rotate. So, as you can see, even though it's showing that it's in 7.5, that tape is clearly moving much slower than that. And does this have an amplifier built in or not? It probably does not. Fortunately, there was a patch cord in the back which has a DIN plug fitted on one end and 4 RCA plugs on the other, marked input and output. I'm able to connect it to my system, and okay, so it's going a little bit slow. So we need to open this unit up and see why I can't change the speed. We'll first remove the 2 reels, and we're going to remove the top cover here. A couple screws that hold the top cover on, and that should give me access to the mechanism. This head cover, oh, this is all part, I think, of the top cover. That lifts out of the way. Somebody's already broken that. So let's get the screws out, and see what's causing the problem. Phillips screws. I'll tell you right now, there's a few things that are causing the problem on this. Slipping idlers and belts is one of them. The real culprit was discovered after I let it sit overnight and turned it on the next morning, only to find out that we still had a problem that needed to be resolved. Looks to be 3 flathead screws in the top, here, and over here as well, that need to be removed. Yeah, there we go. That'll remove the top cover and probably the bottom too. Okay, this is our speed selector. What's interesting is that this speed selector was stuck before, it wouldn't move. So let's just see whether it moves correctly now. It doesn't move when the power is on. Okay, it looks like it's probably going to change the position of an idler down below, so we need to remove the chassis. Okay, there should be 2 more screws here that holds the chassis into the base. Again, they are flat slot screwdriver type screws. Looks to be 2 more screws to hold the chassis in place. I think this one, and there's another one over here. I think those are the 2 that have to come out. Never taken one of these apart before, so I'm kind of learning as I go, because the Germans did things different than everybody else. But I think that might be what holds the chassis in place. Let's see if it'll lift out of the box. Yes. So that holds the chassis in place. I'm going to remove power. Oh, it already did. Already removed the power. So let's remove the chassis. You can see the drive idler right here. This drive idler is what moves. See the rubber tire right there? This is what moves up and down to select the tape speed as I move it. You see, for 7.5, 3 3/4, and 1 7/8. Love the selector switch to select the voltage. Okay, so this is 1 7/8. If I turn it on, we'll see the flywheel start to rotate. You can see how fast it's spinning here. Go to the next speed up. You can see it's spinning faster. And it's spinning even faster. Can't tell really on camera, but I can certainly see how fast it flips my finger out of the way. It is definitely spinning at a much faster speed now. If I slow it down, and there's the slowest speed. So it is changing speed. You can tell what speed this has been used on, mostly 3 3/4, because you can see where the tire has been rubbing for the 3 different speeds. The one in the middle is where it's been sitting most of the time. So I'll thread the tape up. And turn it on. And we'll put this on at the fastest speed. There we go. This should be 7.5. I think this tape was recorded at 15 IPS. Okay, that's really slow coming up to speed. I think we got a slipping idler and possibly a slipping belt here. A little bit slow getting up to that full speed. slipping a little bit. Sounds like the idler might be slipping a bit. We'll try some rubber renew and see if that'll help get up to speed a little quick. Actually, I think this belt here is probably why it's going a bit slow. This belt is slipping. How this one operates, got a one motor over here. This motor is used to drive this idler in the middle, which is also what is used to drive the capstan. You notice that it's slipping. I can make that belt slip. It's not broken, but it certainly is slipping a bit. It probably could use a refreshed rubber belt, but the problem is finding one for a unit that's as old as the hills as this unit here is. As you can see, for fast forward and rewind, it struggles. For play, it uses this idler over here. We'll try cleaning up this belt a bit, see whether I can get some more life out of it. I'm just going to clean this belt up with some cleaner. See if this will give me a little more. Same with this belt here. We'll clean this belt up as well. I'm just going to use some isopropanol. If you're wondering what I've used, I used rubber renew on the idlers, I use isopropanol on the belts. So now that I've cleaned off the that belt it is slipping a bit, but it's a lot more torque than it had before, that's for sure. Rewind. Just try putting another tape on here. One that's recorded at 7.5 and see how it sounds. Alright, 7.5 IPS. Nope. Gotta auto stop. So we're going a little slow, it sounds like, doesn't it? I think my belt's, I don't think it's the belt that's slipping now, because watch all the torque it's got and fast forward. Oops. And rewind. Now remember, this is using the same belt. It's got plenty of torque. I think we need to put some rubber renew on the idler underneath. That's where it's slipping now. After dressing the belt, looks like the belt is now transferring all the torque from the motor to this midway pulley. So now I just need to get to the idler on the bottom. The idler is right down here. Let's just see, I've still got some rubber renew on here. I tell you got to give it to the Germans for their design. They actually use the power switch here, which operates this lever here. If you can, I don't know if you can see or not. Can you guys see the idler? Here's the idler here. The idler is actually pulled into place by the power switch. So when the power switch is depressed, it actually does engage it. And now that the rubber renew has dried, it actually has quite a bit of torque, as you can hear. I think that's the belt slipping when I hold the yeah. So now I'm making the belt chatter. So now we've got lots of torque. Let's try it now and see. One more time. That sounds a little better. 10.5. Three and 3/4. 1 7/8. Certainly going the correct speed now. Not slowing down when you press play either. I'm going to slow the idler down or the flywheel down and see how quick it comes back to speed. I think I found the reason why the motor, or why the belt appears to be a little bit on the loose side here. Check out the play on the motor bracket. The rubber bracket that the motor is mounted in is just completely deteriorated. Look at all the play on the motor. The motor sits in a rubber support, and as you can see here, if we look at the belt, look at the tension on the belt. The motor is sitting low. The belt is looser, right? This will affect the tension on that belt. But you see how the play on the motor here? One other thing about the design of this is not just the motor. This is actually the power transformer as well, believe it or not. I know, it's hard to believe, right? But look at all the windings it's got. It's got the primary and secondary winding for the amplifier, and it's also the motor. So the motor and the main and the transformer are all one piece on this unit. It also says 50 hertz, but it looks like maybe someone may have changed the pulley, because it sounds like it's running the right speed for 60. Power switch is over here. This is the power switch. Watch when I press the power button. It moves this plastic lever, and that turns, there's the power. You see, there's the switch. It's kind of a neat way of designing things. But that motor certainly is loose. Notice the switches on the board here for when you change modes, like, where's it here, go into play. All these little separate boards that are, I don't know if they're plugged in or whether they're, I think they're plugged in. Now these are modules. They have all these little separate little boards here that plug in to the main board. Plugs, just the perfect setup to cause intermittence. When you enter play, this big solenoid engages and trips that switch. We'll lubricate the capstan bearing. I know I could take this all apart, but get some oil down into the bearing. That's gonna keep it going for a while, I think. So let that lubricant soak down into the bearing. It's a sintered bearing, so it should absorb some of it into the actual bearing itself. Push back down the bearing cap there to keep keep any dirt out of it and hold the oil in. Gotta do the same for the bottom bearing. So I let it sit overnight, and when I checked it in the next morning, I found we still had a problem. Okay, I've discovered that this unit actually has a motor problem, even without the motor on. After it sat for a while, listen to the motor. Slow. It has virtually no torque. Like, I can stop that without any effort at all. When the belts are on, I'm going to have to pull this motor out and see if we can make it work better. But with the belts on, even though the belts aren't real super tight, you'll notice that if I stop this from turning, I can stop the motor. Right? Literally stop the motor. So we have a motor problem on this one. And I think the motor is released by removing this screw here. This should remove a bracket. I'll just turn off the power before getting too deep into this thing. So let's just remove power. Let's see if I can get this motor apart. It may be just the bearings inside are gummed up. That's what the hope is it's just going to be something that I can clean up. I just don't know exactly how the motor comes out. Looks like I got to take off this tape reel because there's another screw below there. However, the tape reel comes off on this. Of course, the tape reel is held in place by a clip on the bottom here, so I've got to remove that, and then I should be able to remove the tape reel and then drop the motor. Yeah, boy, a lot more work, I tell you. These German units are always lots of fun to work on. I'll just remove, instead of taking that arm off, I'll just remove this right there. Okay, now I can remove the clip from below and remove the reel table. What's going to be the fun part is putting this bloody thing back on after I'm done. That's going to be the fun part, putting the reel table back in. Well, I got trouble getting the clip out, but getting the clip back in after might be fun. And it'll pop off. Got a finger in there just so that it doesn't go flying, because these are another form of the infamous Jesus clip that would take off on you if you weren't careful. There, I got the clip out of here now. Put that out of the way. Now the reel table, hold it in place so it doesn't fall apart. Now the reel table should lift out just like that to reveal the other screw that I need to remove the motor. Remove that screw, and the motor bracket will lift out on the back side. Carefully set it down. Now the motor can lift out. Lift the motor bracket out. One more screw I've got to remove here. Ground screw. Just so that this wire is not in the way. Now I can lift the motor bracket out of the way and lift out the motor, which is also the combination power transformer on this unit. So there are wires connecting it. There's a plug here, if we can undo the plug. Yellow wire facing towards the top of the machine, Okay, now I should be able to open the motor up and lubricate the bearings inside here, because that's where I believe our fault is the bearings are gummed up. Take off this bottom cap. These white wires here actually are just the power leads going to the power plug. So I'm just going to lift the unit out of the way and move it a bit away so that I can set the motor down on the workbench to work on. Get the screws out. And take the motor apart and see if I can free this thing up. I guess yesterday when I was working on this, when I ran it, and it sped up on its own, probably just from it had been sitting around for a while. But when it cooled down, it got slow again, which sometimes happens with motors. Okay, now I should be able to pull the bottom bearing cap off and pull the rotor out like that. And I can see in here the lubricant is all dried up. I wonder if I can remove this pulley. I don't want to apply any excessive force to the pulley. I don't want to damage it. The pulley should pull off this thing, I think. Okay, it just fits on like that. Okay, now I can take the bearing apart and so we can clean it out and lubricate it. Hopefully we'll be able to save this patient. Okay, we'll start by cleaning off the old lubricant from the shaft itself on both sides.
I'm just using isopropyl alcohol to clean the lubricant that is gummed up.
And we'll also clean out the bearing itself. Ugh, look at that crap that was in there. I wonder if this thing's going slow. Same goes for the other bearing on this side. So this is what's called a sintered bearing, and around this sintered material here, which is like finely compressed brass, there's a felt pad that holds the oil reservoir. As you can see, it'll actually move. So how these work is they're what they call a permanently lubricated motor. As long as we don't have any severe scoring on here, which I don't see that there's any real severe scoring. What happens on a lot of these bearings is when they wear out, especially when people have used them for years when they've been dry, is that they get wear marks, and you'll see it on the shaft here, and you'll see it on the bearing itself. This one doesn't appear to have gotten quite that bad yet. It was just to the point where it was slowing down, so we may be able to save the patient by by just soaking in more lubricant and around the bearing. So when you're working on these type of units, what you want to do is you want to fill the oil reservoir up, which is basically the felt pad that's around the side here, and of course get some oil down into the bearing as well, but it's really the felt pad that you want to get saturated with oil, because that's the reservoir, and it will eventually, it'll dry out. So we'll clean out any remaining dried lubricant on both sides. And then proceed to put some oil down into the oil reservoir. And it will actually take quite a bit of oil, like several drops, to fill that oil reservoir up. And what will eventually happen is that oil will saturate through the permeable bearing material, which is basically like pulverized brass that's been pushed together under high pressure. So it's a porous type metal, soft porous metal, and the oil will actually soak into it. So this process is just basically getting the reservoir full of oil for both sides. It doesn't take a lot of oil to do this. When you deal with bearings that you have oil caps that you can fill, that's what they are doing, is they're just filling up the felt material around the bearing, which will then wick its way into the bearing and onto the motor. And essentially I'll just keep applying oil until it stops wicking in. As I apply it, I can see it being drawn into the actual felt pad itself. Once it becomes saturated, then I know that the bearing is full of oil. Then we can start to reassemble the motor. You see that spins nice and freely. Time to reassemble the motor. There are little pins on the motor bracket here that actually fit into little holes in the core. And that's how you know you've got the motor on the right way, because the little holes are only on one side. So this sets up the alignment. That's the switch. Okay, that part goes on. We'll just clean off any excess oil that's gotten onto the shaft here before I put the pulley back on. Obviously I don't want to put any solvent or anything on at this point because I don't want it to run down into the bearing and dry out the oil that I just put into it. This is turning very freely now. This was a very tight fit, so I would expect that it probably will. Press on quite nicely. There we go. There, okay. Let's just apply power and see how this thing spins up. See if it spins up to the right speed. It's certainly sounding pretty slow before, so if I apply power, that sounds a little better already. Yes. Much better sounding already. Next is to remount the motor. Oops. I believe I messed up. I think that wire went onto this side because it was grounded here. I just have to switch it around because the motor goes in this way. So let me just move that wire to the proper side. Oh, gee. The motor's held in place a lot better than it was before, too. Interesting. Just taking that bracket apart. Remember when we were looking at how loose that motor was? And now it's not. Make sure my switch is on the right side here. Yep, good. The switch is going to work. Put that belt around there. Put this belt around here. That'll hold the belt a little tighter as well. Excellent. Well, that's worked out even better. Maybe I'll put a bit of oil onto the, since I've got the real table out, might as well do that one while I've got it here. I can do the other real table without removing it, by the way. I can get at it from the other side. But since I've already got this one out, might as well do it while it's apart, make it a little easier. Okay, now we'll carefully put the clip back on. It's going to be fun. Power plug back in for the transformer, which is part of this motor. And fight with this clip to get this clip back on where it belongs, which is right down here. It's much harder to set these clips, by the way, than it is to take them off, but I work it with a screwdriver to get the clip into place, and I'm going to use just a nut driver over the top of it that will push it down. There, the clip is now set. The other one I can lubricate without removing it because it's located right here. So I can put some oil on that one without actually having to remove it, and that will lubricate that hub. Got that back in place. Let's see if it turns on. Ah, much better. Sounds much better to start. Let's throw a tape on it. Let's see how it sounds. Help if I put on at the right speed. I wonder why that sometimes. I got to investigate that switch. The fast forward switches give me a little bit of trouble. Depending on how I push it, it might try to put it in play or go into fast forward. You can see if I don't push it right, so there must be something on this switch that's not connecting right. So let me just take a look at that. It looks like this is just slipped out of position. This clip is not in position right, it looks like. Supposed to be more like that. Okay, yeah, just this was out of position a bit for the fast forward. So let's put this thing back in its cabinet now, so I can start reassembling it and testing it. Got to grab the cabinet, extend the foot so that the cabinet stands up, so I can turn this around. The fun part, getting these screws back in. These magnetic screwdrivers help. And yes, these screws are magnetic, which makes things a little bit easier. There, now you hear the motor come up to speed like it's supposed to, instead of struggling there like it was before. like this tape path here. Check this out. You haven't noticed. Okay, there's an actual roller that pulls the tape up against and around the erase head to get an erase head, a record head, and a play head. So most tape decks, they see the tape is almost in contact with the heads, but this one here, the tape is actually dropped right away from the heads. And when you enter play, this separate little roller engages to provide good tape contact. Pause is fully mechanical. It just literally pulls the pinch roller away. Now it's time to put the top cover on. The top cover on these goes on pretty easy actually, because all the clips on the front just line up with, you pull the knobs back, pull the speed down to 1 7/8, and the top cover will just sit in place, and these will automatically line up. Just like that. There. That's it. Now it screws in the top and in the front end and the back side, and this one here will be ready for its final test. I still don't understand why they used 2 Phillips screws and the rest of them are slot screws, unless someone replaced these before with different screws, which I guess is a possibility. But I mean, all the other screws on this thing are all slot screws, but those 2 were Phillips. We'll just extend the stand on the back to hold it up while I put the screws in the back of it. And with the stand in the back extended, the unit is designed to be operated in a vertical operation or horizontal. So for our final test, let's thread it up in vertical operation, because this is the way most people operated these decks anyway, isn't it? We'll set our tape speed. And it does have auto stop, by the way. You'll hear it click, the leader. See? Well, I was going to say that this one's done. Should be good for many more years now that that motor has been taken apart and the bearing has been repacked with oil. Should be good for a while. I didn't see any significant scoring to indicate that it's going to fail again quickly, so fingers crossed this thing will be good for another 40, 50 years if it's looked after. Thanks for watching. We'll catch you in the next one. Bye for now.